welcome to Ethics. So today we have something known as art of problem solving, which we basically term as AOPS. So today is the second question that we will be seeing, that how amazing the maths is. You just need simple intuition to solve the mathematics question. So let's see. So we have this question: permutation counting the number of paths through a grid. So grid is what? Grid is basically anything like big table sort of thing. So now how many paths are there to move from the start point? This is our starting point to the finish point. This is our finish point. Basically this point is finish point and this point is start point. Okay. Now it says that you are only permitted to move north, that is basically up. This is the upward direction. So you are allowed to move in the north direction and the west, that is to the left hand side. Hence these are the only permissible movement that we can do. We cannot go to the right of the thing. Means we cannot, suppose we are over here, so we cannot go like this. And suppose we are over here, so we cannot go down also. So these movements are not permitted in the question. So we will be solving it. First of all, let's see one thing, that let me take it on the next page. So you have this 2 by 2 grid. You have this 2 by 2 grid. Suppose you are over here on this point. To get on to this point, remember one thing, that we can go to the upward, that is north, and we can go to the leftward, that is west. So to come at this point, say this point to be A, how many ways? Like we can go by how many ways? We can go like this, suppose, and then going up, but we cannot go left, right? So this is not the thing. And if you observe carefully, that getting on the point A, it is only one way possible, that is basically just going like this. So on coming to point A, like how many possible ways are there? There are only one way possible. Now see from this point, say this point to be B. So similarly over here also you can just go one leftward movement, that is basically going in the west direction. So this is only here it is only one possibility also, because if you go like this up and then moving into the left, till here everything is correct, but you cannot go down, right? So this movement is restricted. So the only thing, the only way that you can go is basically moving on to the left from the start point. This is our start point, say to be S. So over here also it is 1. Let me mark all the things that we will be doing and let's try to observe something. So this was our start point. On getting this point we have only one way. On getting this point we have two ways. I mean one way, sorry. So let's see this point, this middle point, say to be C. So how can we get to the point C from the starting point? Like we can go up from the starting point and then moving to the left direction. Both the movement are correct. Like they are permitted. And we can also go like from the start point, let's say going to the left and then going to the upward movement. So to get to the point C, we have two ways. We can go by either this way or this way. So this is how many ways? Two ways we can get over there. Similarly, like getting on this point D, say this point to be D. If you see it, like there is only one way here also, because you can go just this and this, I mean west and west. From the starting point, you will be going like this and this. Because if you go any other way, like let's suppose we go up and then go like this is also valid. But we need to, like suppose we landed on point C, so to move to point D, we must have to take a downward movement. That is restricted. That is not permitted in our case. So to get to the point D also, we have only one way, right? Similarly, if you see, like to get to the point this over, say to the E point. So to getting on the point E again. Look carefully. If we go north and north, valid case means one way is there, and if you go left and then up, you need to go right movement, right? But right is not permitted. So again over here also it is only one way valid. Now let me have another. Yeah. So we have checked for this point, this point, this point, this point, and also for this point. Now say for example this point, say to be F, and this was our starting point. So in how many ways can you get to the point F? In how many ways you can get? So you can go like either north, left, north. This is the possible thing, right? Or you can go north, I mean, this is north, 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 and then left. I mean, this, and this. So this is also valid. Or also you can do one thing that you can first go to left and then up, right? Going to left and then up and then up. So how many ways? How many possible paths are there? So there are three paths. Okay. Now let's go on to point G. So in how many ways can we get to the point G? So if you see carefully, like we can go like left, up, left, right? This is permissible. I mean, this is permitted. So this path is valid. And we can go also like left, left, and then up. This is also valid. Or we can also go like up, then left, and then left. I mean, following this path. This path I'm saying. So these are here also three ways. So at this point we have three ways. Now I will have to clear some to get some space over here. I hope you are getting like what I'm doing. I'm just taking, I mean to understand the question, because this is not our question. We have the larger grid than this. So first we will always try to understand the simpler case. That is that we are doing onto the 2 by 2 grid. And then we will move on to the larger grid by observing the pattern. So now for this point, this is the only point left. Say it to be point O. So and this is our grid, this is point O, this is point S. So in how many ways can we get to point O from our starting point S? So let's observe it. Um, upward movement, left movement, left movement. This is valid. Left movement, upward movement, upward movement. Two valid cases, and then see upward movement, left movement, and upward movement. Three valid cases. Then what you can do? Left movement, upward movement, left movement, then upward movement. We have again two valid case, two valid case. Let's see, are there any more also? So, like we have taken, no, we have not taken. Suppose we can go up movement, up movement, and then left movement. Right? We have not covered this. This is not, no. So we have not covered it. So again over here, one more way. And is there any more way? Let's see. So if we go to the left side, and then on the left side, yeah, I mean to up, and then to left. I mean following this path, yeah. So we have these 6 ways. And if you try more, like if you try to find out any other way, either that path will be not valid or that will be the repeated path. Like if you try to do it like randomly, if you say this path, this, this we have already covered in over here. And if you try to go like moving up, then this, then down, then this, and then up. So this is not valid. We cannot go to down. So this is not valid. So how many ways we have that? 6 ways, right? We have 6 paths to go to point O from point S. So we have this thing. Let me have it on the next page. We have found, let's see, this was 1, this was 1, this was also 1, this was 1, this was 2, this was 3, this was 3, and this was 6. So if you see one thing, you can get pattern. Like say in this rectangle, adding this, we are getting this. Are you seeing it? Again, now in this rectangle, adding this, we are getting 3. 2 plus 1 is 3, right? Let's see, we have this pattern over it. Like let me observe for other values also. Like is it values in the whole grid or it is valid on the initial points only. So 1 plus this 1 plus 1 is 2. This 2 plus 1 is 3. This 1 plus 2 is 3. This 3 plus 3 is 6. Basically, if we have this sort of thing, whatever the number is over here, the number on this corner will be a plus b, right? Here, like suppose, so on this corner, like this corner, it will be 1 plus 2, right? And this is our rectangle on this case. So going back to our problem, this is our problem. So since we have already find out that this is path number 1, I mean only one way to go. Over here also it was one way, over here also it was one way, and this was how much way? This was 2, right? And this was 3, and this was 3, and this was 6. So now, like for this, say for this point, say this point is m. I'm taking just a random variable. They might repeat, like I'm taking over m. So if you see carefully, to get to point m, there is only one way. But you can just go like this. Because if you take any other point, I mean if you take any other way, you will need to have move on to the one step down, right? And but that is not permissible. That is not permitted. We cannot go down or east. So we cannot go. So to get onto point M, we have how many ways? We have one way. So this is how many way? One way. And since we have find out the pattern, so we will be doing 3 plus 1 is how much? 4. And this 4 plus 6 is how much? 10. Okay. Now, say for this point is some n. So to get on this point, how many ways? There is only one way. Because if you take any other path now, because if you go like what is this one path? It is basically going up straight from over here to over here. This is the only one path. Because if you take any other way, like if you take any leftward movement, you will need to have a rightward movement to get on this line again. So we cannot do like that. we are not permitted to move on to the right side. So to get on point N, again we have one point. Over here also we will be having one point. If you have understood that how we have get only one path for N, so you will understand that over here it is also one, over here it is also one, over here it is also one, and over here it is also one. So if you have doubt in this, you can ask in the comment section. I will try to clear it. I don't think you will have, but if you have, then no need to get, shy. You can always ask. If you are asking your doubt in maths, that's a very important thing because students generally pretend to be getting understood. Like they think that they have understood, but in somewhere in the head, they are like, yeah, they are like the question could have been more clear. So I don't want you to have this feeling. If you have doubt, then you may ask in the comment section. So now if you observe this rectangle, this big rectangle, so in this 3 plus 1 is how much? 4, and in this 4 plus 1 is how much? 5. Okay. Now say this point to be point L. In how many ways can we get to the point L? So let's do it. So to get to the point L, like we cannot come over here and then go down because going down is not permissible. We cannot come over here and go like this. So this is also not permissible because the rightward movement and downward movement are not possible. The only thing is that you reach to point L by upward movement or leftward movement, right? But leftward movement cannot be like there is no path over here. There is no path. It is blank. There is no path. So leftward movement is not possible. The only thing is that this upward movement, right? So you can get to point L by upward movement only. So let's say for example, this is city B, this is city A, and this is city A, B, C. So if there are 6 ways and there is only one way, there are 6 ways to move from city A to city B, and then if you reach in the city B, there is only one path. There is only one path to go from city B to city C. So say for these paths are 6 ways are like path 1, path 2, path 3, path 4, path 5, and path 6. So to move from city A to C via B will be how many way? Will be how many way? And say this path to be path R. So either you are going through path 1 and then R, you are going to path 2 and path R, path 3 and path R, and so on till path 6 and path R. So there are 6 possible paths to go from point L, from a starting point, to go from city C from a starting point, that is A, right? So since there is only one path over here, so what will be the number that we are getting to move to city B from the starting point will be the same to move to city C from the starting point. Since over here also there is only one way to move from this point to point L, right? So to move to point L, there will be 6 ways. So I hope you have understood. Now let me clear the space. There is no formula associated over here. Like that's why I am covering this problem in art of problem solving, because there is no formula required to solve this question. It's just analyzing the path and getting a thought over it. So Now again, now if you see carefully, like this, suppose this rectangle. On this rectangle, this corner is 4, this corner is 6, so this will be how much? This will be 10. And in this is 10, this is 5, so this will be how much? 15. Okay. So now moving on to point this. So in this triangle, if you can see, this will be how much? 10 plus 6, 16. Okay. Now, see in this rectangle, the corners are 1 and 10, so it will be how much? 11. And to move to point this, say this point to be P. I will explain that how many ways there will be to move to point P. Since on point P, uh, since on point P, we can move by either going to top or going to left, because these are the only permissible movement. So on point P, we are not having any leftward movement. We only have this upward movement. So as I have explained you that why it is 6 over here, we can also say that this will be one path only, because to move to this point, there is only one path, and there is only one path to move from this point. So this will be only one way, right? So to move to point this point was our how much? P. So to move to point P, we have only one way. Now again, clearing the space to have clarity. So we have over how much? 1. And this 1 plus 1 is how much? 2. And this 11 plus 2 is how much? 13. And this 2 plus 1 is how much? 1. And this 13 plus 1 is how much? 14. This 14 plus 1 is how much? 15. Okay. Now this 16 plus 11 is how much? 27. This 27 plus 13 is how much? 40. This 40 plus 14 is how much? 54. And this is how much? 54 plus, wait. I think I have committed some mistake. This was 13, right? This was 13. But over here, yeah, wait. Hang on. I've explained something wrong this side. Like, for this, there is only one way. But here it is not one way. Wait. So, since we have 16 plus 1 is how much? 27. And this 11 plus 1 is how much? 13. And this 2 plus 1 is how much? This is 3. So now we have this grid possible. So this will be how much? 16. And this is 40. This is how much? 40 plus 16 is 56. And if you see this, in this grid, 16 plus 1 is how much? 17. So this will be how much? It will be 73, right? Okay. Now, this 16 plus 10 is how much? 26. This is 26 plus 27 is how much? 53. And this 53 plus 90, 40 is 93. And this 93 plus 56 is how much? This is 149, right? 6 plus 3, 9, and 9 plus 5, 14. And this 73 plus 149 is how much? This is basically 222. Again, now this 26 plus 15 is how much? This is 41. This 41 plus 53 is how much? It is 494, right? And this is how much? It is 187. This will be 187 plus 149 is how much? 336. So to move to point finishing, we have how many ways? We have 500 58. So our answer is how much? 580 ways or path. So this was our question. What I did, let me brief it shortly. First, we have checked the pattern in our smaller grid. So by observing in the smaller grid, we get to know that we are doing sum of these corner points to get this corner point, right? Have concluded over here that sum of this point will be equal on this point. So we have just done the problem, and I hope it was very much clear to you, because there was no formula associated to it, and maths is very interesting when the formulas are not associated, because maths is not only about the formula. Maths is not only about the cramming formula and just applying, like you are given that say x plus y equal to 7 and x square plus y square is equal to say for example 14. So find xy. Maths is not about just only putting the values kind of thing. The real maths is doing the thing which don't actually require the formula type of thing, and that's the math, and that's the art. Maths is an art. So we have done the art of problem solving too, and I hope you have understood the problem very well. If you have any confusion, you can just drop your query in the comment section. So till then, take care, and thank you.